Hello, my name is Ron Dorn. I'm a physical geographer at Arizona State University. The purpose of this assignment is to give you an overview of an assignment called the Tour of Northern Arizona. The best way for me to explain this assignment is by walking you through the Canvas page that discusses the assignment. There's another location where you actually turn in the assignment. Excuse me. The Tour of Northern Arizona is available to you if you've completed these prerequisites here. The Hawaii Lightning, Grand Canyon Microclimate, and Grand Canyon Geology Topography Labs, the specific stages, everything except for the essays. If for some reason you were able to access this assignment and actually turn something in and not having completed all these labs, we recommend that you not do that because you won't get your assignment graded until everything's done. Canvas should have been programmed to prevent you from turning in this assignment until everything else is done. We need you to have the background of finishing those labs. The essence of this assignment is that you may someday return to the Grand Canyon or go to the Grand Canyon. And the most likely pathway of you going there is via Flagstaff. So here's an overview map of the different stops that are on a potential tour. They start in Flagstaff, pretending you come up from Phoenix or from Las Vegas, and you might hike around the San Francisco peaks. You might drive to Sunset Crater, you might drive around through to Wapatki, and then visit the South Rim, hopefully the North Rim, and maybe even take a tour of a raft down through the Grand Canyon. So what you're going to do is pick any number of the different locations along this tour. So this website page has a lot of links, all the different potential stops. Eldon Mountain, Humphrey, Schultz Pass, you name it, you have a lot of things to choose from. So I'll walk you through an example here of one of these locations. Let's say that you're interested in visiting the top of Humphreys Peak and you take the road to Snowball. So when you click on the link that you see in the lab or in the PDF file that's linked into the lab, you're taken to a Google Street View of the road up to Snowball. Now, this image was captured in October of 2016, and it's a series of images. And one of the reasons why I included this as an example is you can see a thunderstorm building in the background. The monsoon season typically ends in mid-September, but it can squeak into October. And so there's actually a thunderstorm building here. What do you do in terms of the interpretation here? You have a variety of choices in physical geography: climate, the biogeography, the soils. But in this particular setting, I would recommend that you apply what you learned in the game environment. So to specifically apply what you learned in the game environment is to go to this location in the Northern Arizona Lightning video games. When you click on the links, you'll be taken to a Google Street View. And if you look at the URL very carefully, there's a latitude and a longitude of this particular location that's embedded in the web address. So you simply plug this in to the game environment. And here's a captured screenshot that's in Canvas as an explanation of what you see in the Google Street View and then what you see in the game. It's a whole bunch of lightning clusters in this particular location. And so the example that I wrote up here in the video game is that what you learned in the game lab is that there's two major processes that build up thunderstorms that can generate lightning clusters like this. One of them is out on the flats where you get a lot of surface heating and you get convection building a thunderstorm. The other process that tends to happen on the slopes of mountains is you get upslope winds that are explained in much greater detail in the lab, but you get differential heating between the surrounding environment and heating up of the slopes that pull the air up the mountain slopes. You build up thunderstorms and you can get clusters of lightning strikes as long as the thunderstorms aren't pushed away from the location. So as long as the regional winds aren't blowing that fast, you can get lots of lightning clusters in one particular location. Another example of a tour stop that you could do, and this is really nerding out, if you have a strong geology background, you might love something called the Great Unconformity. So one of the stops along the Grand Canyon is this Great Unconformity, where the Google Street View of going down the Grand Canyon shows the unconformity of an old surface eroded down with then very old geologic deposits laid down upon the old erosion surface. And this is what it looks like in the game environment. All this stuff is the really old rocks that were beveled flat by very old ancient time in the so these are Neoproterozoic rocks, super old rocks that were beveled flat, and then you get Paleozoic rocks, which are quite old, that are deposited on top of them. So this is a really nerding out one that would go above and beyond the game. An example of one that is dead center in the game is a visit to Cedar Ridge, where you can apply your knowledge of what you learned about microclimate to interpret the different temperatures you see on either side of the west and east facing side of the north-south Cedar Ridge. The idea here is that you're not just repeating back what you learn in the lab, but I'm hoping that you're practicing applying what you've learned so that when you go on this wonderful vacation to Northern Arizona and the Grand Canyon, you can practice physical geography science by making hypotheses. And then if you're wondering about if the hypotheses are real or right, when you actually are on vacation, email your instructor or email me and let's discuss it. Take pictures of yourself on vacation, what you're seeing, and we can analyze whether your hypothesis is reasonable. Have fun applying and earning additional points in this hopefully creative and enjoyable way.